At the moment, you're in the engine room of the vessel Wes Amelie. It's a container ship. We are on board here to convert the main engine from the existing 4860 into a 5160 DF engine, which will then be able to run on gas.
The main advantage of dual fuel is the flexibility of still having the option of using conventional fuels, but also using LNG, which helps in supporting reducing emissions. It's better for the environment. It helps also in the in-between time scenario until lots of possibilities to bunker LNG are given to have the right flexibility.
The biggest challenges we have, mainly the amount of space we have on board, is extremely limited. It's a very small engine room, so manoeuvring parts in and out is extremely difficult. Also, the amount of parts we have, moving them to and from the ship, the logistics is extremely difficult.
We are at the spare store at the yard, where we have about 160 boxes with all the components we need to retrofit the engine.
We decided to convert our vessel Wes Amelie because the environmental regulations become more strict and wider, and since 2015 the MARPOL Annex 6 is enforced, and in these regulations the sulfur content has been brought to a very low line downwards, and emission is the key at the moment, and everybody's trying to reduce emissions, and that's why we choose to stay in our trading area and being better as our competitors. The advantage is that we can maintain running the ship in our home area. Our home area is the North Sea, the Baltic Sea, and in these special areas the environmental regulations are the hardest at this moment, so we can stick here trading with our partners and maintain our trading area.
We started already 3 years ago together with MAN and TGE, where we investigated the possibility to convert the vessel. That went out quite positive, and then we started to structure the finance for this project. That took a while, but 1 year ago we were able and we were ready to sign the contract, and as you can see here, everything is in full swing. We were applying for support from the Ministry of Transport, and fortunately we were successful with our project presentation, and obviously this project fits perfectly into the strategy the Ministry of Transport was following regarding LNG, so that was a perfect match actually.
Hier haben wir es bei diesem Schiff der Wesselsreederei ja mit einem Pilotprojekt zu tun. Wir wollen das aber standardisieren, dass diese Umbaumöglichkeiten besser gefördert werden und hier auch mehr Reedereien dazu kommen, diese Umbaumaßnahmen vorzunehmen. Deswegen bereiten wir eine Förderrichtlinie vor, die passgenau auf diesen Punkt kommt, die dann, ich denke, ab 2018 die Mittel ausreichend bereitstellt, dass Projekte aller Art auch gefördert werden können.
The specific characteristic of bunkering LNG is that LNG is a liquid natural gas with a very low temperature of minus 160 degrees, and because of the not existing knowledge on the crew side as well on the yard, we have to support them to ensure that they understand the safety procedures and the handlings well.
We have to prove that Wes Amelie is working on gas, and we have to collect all this data within the next half year and maybe another year, and to prove this information to the public. And then of course we would like to convert her sister ships, and maybe we could help other ships being converted as well. On the long run there will be no alternative to LNG. The emission control areas will be widened. Maybe Spain and France and also the Mediterranean will join the SECA zone, and even the limits will become lower. So there is really no alternative on LNG.
The main advantages of LNG as fuel in the marine sector is of course the environmental aspect. Specifically when you compare LNG with MGO, you can really recognize that the particle emission is zero compared to MGO. The sulfur component is also close to zero, and the NOx will be reduced compared to MGO by 85%. It's at the moment one of the most environmental fuels in the marine sector.
We would recommend any future-minded customer to have some thoughts about this. The environmental legislation really makes it necessary to think about the future of fuel on ships. And it might be a very good business case for the future to secure already now an operating fleet with what is coming also to us.
So what exactly is an exhaust gas scrubber, and how does it work? An EGS is an air pollution control device that is used to eliminate either particles or gases, or sometimes both, from industrial exhaust streams. There are three types of exhaust gas scrubbers: open loop, closed loop, and hybrid. An open loop EGS uses seawater to neutralize the acidic effluent from the scrubber. A closed loop EGS uses a reagent such as caustic soda to neutralize the acidic effluent from the scrubber. A hybrid EGS can use either seawater or caustic soda. Exhaust gas scrubbers operate much like a car exhaust system. As the engine operates, it creates exhaust. Historically, this exhaust went directly into the atmosphere. With an EGS, sulfur oxide, particulate matter, and other pollutants are removed as the exhaust passes through the scrubber tower by means of a water spray manifold inside the tower. Water mixes with the gases and removes the unwanted pollutants. During this process, the pH of water decreases and becomes acidic. To neutralize the pH, caustic soda is added directly into a recirculation tank. This automated system maintains a neutral pH of around 7. The mixed water, or effluent, that remains is sent to a treatment unit, which removes the majority of pollutants. The treated effluent is passed through a series of sensors, and if the water meets the proper criteria, it is discharged overboard.